Left recursive grammars are a problem when we use left recursive parsers. And we're going to talk a little bit more about what that means when we get to it in chapter 4 or 5. But for now, let's look at what left recursion is, and then we'll talk about how to solve it or how to fix it. So if you look at the grammar on the left, here we have an expression, can take the form of an expression plus a term. Or it can be a term. And this is left recursion right here, where we have the non-terminal on the left, or the head, and then the first symbol to appear on the right-hand side is that same non-terminal. And so what we get is a parse tree that can look something like this when we use a certain type of parser, and it just goes on and on. Okay, and that's a problem. So how can we fix that, or can we fix that? And the answer is yes. Let's look at this grammar here. Now, this is a general grammar, and it's using Greek symbols, so alpha and beta. And the book uses these not to be non-terminals or terminals, but to be stuff. So alpha and beta, it means stuff, or some set of terminals and non-terminals. Okay, so if we have a production rule that is A can take the form of A followed by some stuff, or beta, we can actually fix the left recursion there as follows. We change the grammar to be A can take the form of beta followed by R, which is a new non-terminal, and R can take the form of alpha, R, or epsilon. So we've added a few things here. We've added a new non-terminal R, and we've also added this epsilon. Now, is this the same language as this? And the answer is yes, and we're just going to trust it for now. So let's look at how we can fix our original grammar. So we have expression can take the form of term. Well, let's actually look at what these are. So this would be like A, and this would be alpha, and this would be beta, right? If we look at that. And so now we can write the new grammar. We take beta, which is term, followed by R, and R can take the form of alpha, which is plus term, followed by R, or epsilon. So one thing to note here also is that this production rule is right recursive. Right? We have that symbol R, and it is also the last symbol in that production rule. Okay, so let's do a really quick, simple example to see this in action. So let's say, I'm making this up, AX or Y. Okay, so that's left recursive. And what is this language? Well, it's a bunch of X's followed by, or a Y followed by a bunch of X's. And is that legit? Well, let's see. By this production rule, A can take the form of Y, so that goes to A. And then we have A takes the form of AX, and then A takes the form of AX. And so there's the parse tree for that one. Now, let's convert that using our conversion tool. A is going to be beta R, which is YR, right? Y is beta. And R is going to be alpha, which is X, R, or epsilon. So let's see if we can parse this same string of terminals using that one. Okay, so what do we have? We have R goes to X, R. So here we have an X. Can that take the form of R? Or can R take the form of just an X? Well, yeah, it can, because what we can do is we can add in an epsilon, which is the empty string, and then we have r takes the form of x. Let me fix that there. R takes the form of epsilon, and r takes the form of x, r. R takes the form of x, r, and r takes the form of y, r, by the first production rule. And so we can see that both grammars can parse that same string of terminals.